All right, so we have one of our textbook problems where we're given the gamma distribution with parameters of alpha equals 2 and beta equals half. What we're going to do is we will find the PDF of y and w. So in order to do that, we're going to be finding the values of x1 and x2 in terms of y and w. Now, there are multiple ways to do this. So first what we're going to do is, here's one of the ways that we can do. So we can first find what our x1 is. We can rewrite x1 as x2 times w. That's what we get from this part. And we can rewrite this equation as, so y squared is equal to x1 plus x2. Now, notice that this equation can be substituted with this one. So we can rewrite basically x1 is equal to w times y squared minus x1. So x1 is the same as w times y squared minus w times x1. So x1 plus w times x1 equals w times y squared. So x1 times 1 plus w is equal to w times y squared. x1 is equal to w times y squared divided by 1 plus w. So now that we know what our x1 value is, we can go ahead and find our x2 value. So x2 is equal to y squared minus x1. So x2 is equal to y squared minus w times y squared all over, not all over, w2 minus 1 plus w. So x2 is the same as y squared times 1 plus w minus w times y squared all over 1 plus w equals y squared divided by 1 plus w. So we have our x2 and we have our x1 now. Now that we have our x2 and x1, we can go ahead and calculate our Jacobian matrix. So I'm just going to rewrite what my x1 value is. So far we know that our x1 is equal to w times y squared all over 1 plus w. And then we have our x2 equals y squared divided by 1 plus w. So in order to create our Jacobian matrix, what we're going to be doing is we're going to first find our partial derivative of x1 in terms of y, and partial derivative of x1 in terms of w. We have our partial derivative of x2 in terms of y, and then partial derivative of x2 in terms of w. And this is the same as rewriting this. We have, so derivative of, we're going to be taking derivative of this value in terms of y. So taking the derivative of that in terms of y, our w over 1 plus w is going to be constant. So the derivative of y squared is just basically 2y. So we have 2 times wy squared divided by 1 plus w. And here we're taking the derivative in terms of w, so that will yield y squared divided by 1 plus w all squared, because we're going to be using the quotient rule. I'm not going to go over too many details, but it's kind of understood at this point. And we're going to be and here derivative of x2 in terms of y, you have 2y divided by 1 plus w, and here it's going to be negative y squared all over 1 plus w all squared. I'm going to be multiplying these two values and then subtract by the multiplication of those two values. So multiplying these two values will give us negative 2 times w y cubed all over 1 plus w cubed, and then subtracting these two values, you'll get, subtracting the product of these two values, you will have negative 2y cubed divided by 1 plus w all cubed. Simplifying this would give us negative 2 times w y cubed minus 2y cubed all over 1 plus w whole cubed. And that is the same as saying we can pull out negative 2y cubed out, so we have negative 2y cubed times 1 plus w divided by 1 plus w all cubed. These two can cancel, reducing the term, so you have negative 2y cubed divided by 1 plus w squared. Now that we have our Jacobian value, now that we have our x1 and x2, we can go ahead and find out what our joint distribution here would be. So we're going to find this joint distribution of f of x1 and x2, and the joint distribution is basically 1 over square root of 2 pi times x1 to the power negative 1/2 times e to the power negative x1 over 2, and that's for the x1 part. Same thing goes for x2, so we have 1 over root 2 pi times x2 to the negative 1/2 multiplied by e to the power negative x2 over 2. Now that we have our distribution, all we're going to do is we're going to be substituting, so we're going to find fy of w, fyw for fyw, and that we're just going to be substituting values in, so we have 1 over square root of 2 pi times wy squared divided by 1 plus w all raised to the negative 1/2, and then so we have our exponential distribution for, we have negative wy squared divided by 2 times 1 plus w, and then multiply this by 1 over square root of 2 pi, and this is multiplied by y squared divided by 1 plus w all to the power negative 1/2 times the exponential value of, negative y squared divided by 2 times 1 plus w. So now that we have our distribution, we're going to be multiplying our distribution by the absolute value of Jacobian that we found out earlier. So simplifying the above distribution, we can multiply these two together, and that's just going to give us 1 over 2 pi. And if we multiplied the remaining values, like these two, we will get wy to the 4th divided by 1 plus w squared, all raised to the negative 1/2, times 2y cubed divided by 1 plus w squared. This is the absolute value of Jacobian that we are substituting in, and all of this value is being multiplied by the exponential function, or the exponent, or e to the power. So let's combine these two, and when we combine those two, you're going to get negative y squared divided by 2. Simplifying the above equation, we get 1 divided by pi root w times y divided by 1 plus w times e raised to the negative y squared over 2. This is our PDF of fx1, x2. Now that we do have our PDF, we can just calculate our marginals for y and w. So we can go ahead and find our marginal distributions for y and w. So if we want to find the marginal distribution of y, we're going to be integrating in terms of dw. So you have, okay, just a second. So all I'm doing here is I will pull out my y's and move in all the w's on one side. So because my y's are my constant, and we're going to be integrating in terms of w. So if we rewrite that equation, we have y divided by pi multiplied by e to the power negative y squared over 2 times the integral from 0 to infinity for 1 divided by square root of w times 1 plus w dw. So let's go ahead and solve that. This part is just a constant. So before I go ahead and solve, and if I were to find the marginal for w, I would basically pull out all my w's, and I'm going to be integrated in terms of dy. So I would have 1 divided by pi times root w multiplied by 1 plus w, and all of this is integrating from 0 to infinity for y e to the negative y squared over 2, and that is integrated in terms of dy. Now it seems like the integral for this is fairly simple, so we can just go ahead and solve the integral for that. So this looks like a simple u substitution, so fw of w, this is a simple u substitution, so you have u equals y squared over 2. If we were to take the derivative of u, that's just going to give us y dy, because derivative of y squared is just 2y. Simplifying it gives us y dy. So now our new distribution, so fw of w is equal to 1 divided by pi times root w multiplied by 1 plus w multiplied by e to the negative u du. This will give us 1 over pi root w times 1 plus w multiplied by negative e to the u, and we're going to have from 0 to infinity. So that would basically yield us negative e to the negative infinity minus negative e to the negative 0. And that should simplify to 1. And therefore, our f marginal for w is same thing as saying 1 over pi root w times 1 plus w. And this is only valid for all w values greater than 0. So now that we know our marginal for w, we can substitute this value back into the equation and find the marginal for y. And if we wanted to do that, so we wanted to find fy of y, it's the same as saying y e to the negative y squared divided by 2. And if we were to integrate this from 0 to infinity, we have 1 over pi times root w times 1 plus w dw. Pull out all the constants, integrate it in terms of w. One thing we can automatically notice is that we have already found out what the marginal for w is, and since this is the PDF of w, we know that this value is going to equal to 1. And because this whole value already simplifies to 1, we have our f y is equal to just y e to the negative y squared divided by 2, which is valid when y value is greater than 0. So now that we know what our marginal for y is, so and so, and our marginal for w is 1 over pi root w times 1 plus w, and this is valid for all w values greater than 0. So in order to give you a quick summary, what we did is we first found out what our x1 value is, x2 value is in terms of y and w. Then we find our Jacobian values. Once we find our Jacobian value, we substitute it into our joint PDF, and we multiply it by our absolute value of Jacobian. And once we do find the absolute value of Jacobian, we simplify it to find the PDF. Once we find the PDF, you can find the marginals for y and w from that PDF. And when you're finding the marginal of y, we're going to be integrating in terms of w. And when you're going to be finding the marginal for w, you'll be integrating in terms of y. Once you find the marginal of w, you can substitute that into the equation for fy of y, and that just simplifies to y e to the negative y squared over 2. So these two solutions are interlinked to each other.